Hi everyone, my name is Aksa and today I will explain about introduction of Mars. Respected judges, teachers and dear audience, thank you for giving this opportunity to present our Mars mission design. Our team name is AD Mars Pioneers and our mentors are teacher Niwal and teacher Minahil. Our team members are Aksa, Simab, Som and Rabi Azam. Today we will present our complete Mars mission design which explain how astronauts can safely travel from Earth to Mars. Live there for several months, carry out scientific research, and return safely to Earth. Our mission is not just a theoretical idea, we have designed it as a realistic future mission by combining science, engineering, and human operation. We have also included practical solutions for the challenges astronauts may face while living on Mars. Now, let's begin with the Mars overview. Our mission has five main objectives. The first objective is to transport astronauts safely from Earth to Mars. For this, we can design a spacecraft with life support system, radiation protection, communication system, and safe landing technology. The second objective is to establish a self-sustaining habitat on Mars. The habitat will provide astronauts with oxygen, water, electricity, food production, medical facilities, and a safe place to live. We have also included recycling system and ISRU technology so that astronauts can use local Martian resources instead of depending completely on Earth. The third objective. The third objective is to conduct scientific research. Our astronauts will study Mars geology, climate history, rocks, volcanoes, and ancient river to better understand how the planet formed and changed for over billions of years. The fourth objective is to explore water resources and search for signs of past or present life. We will use advanced scientific instruments to detect underground ice, collect samples, and analyze them inside our habitat laboratory. Finally, our mission will test new technologies such as astronauts, robots, drones, water extraction system, oxygen production, and sustainable life support systems. These technologies will help prepare for future long duration human mission and permanent settlements on Mars. Next slide. Mars is the fourth planet from the Sun and it is often called most Earth-like planet in our solar system. Although it is much colder than Earth, it has many features that make it one of the best places for future human exploration. Scientists have discovered vast ice beneath the surface, changing seasons, volcanoes, valleys, ancient river channels, and dried lake beds. These discoveries suggest that billions of years ago, Mars may have had a warmer climate and flowing water. This is one of the main reasons why scientists are interested in exploring Mars. By studying its surface, climate, rocks, minerals, and water resources, we can better understand the planet's history and investigate whether life existed there. Our mission design provides a realistic and practical plan for traveling to Mars, building a safe habitat using local resources, conducting scientific experiments, and helping astronauts live and work safely on the planet. We believe that this mission can become an important step towards future human exploration and the possible settlements on Mars. Next slide. Every Mars mission must be launched at the right time. We cannot launch whenever we want because Earth and Mars keep moving around the Sun. Our mission will launch during the best launch window, which occurs about every 26 months when the two planets are in the most suitable positions Launching during this period reduces the travel distance, saves a large amount of fuel, and shortens the journey to about 6 to 7 months. It also reduces mission cost and lowers the risk for the astronauts. Before launch, we will carefully check the spacecraft weather conditions, life support systems, fuel levels, and communication system to make sure everything is ready. Choosing the correct launch window gives our mission the highest chance of reaching Mars safely and successfully. Thank you.
Everyone, I am Rabia and I am talking about landing site and science. Selecting the right landing site is one of the most important part of our mission design. After studying different regions of Mars, we selected Arcadia Planitia because it meets almost all the requirements for a long-term human mission. This area contains large underground ice, drinking water, oxygen, fuel so ISRU technology. And other advantage is that the surface is wide and relatively flat. This makes spacecraft landing much safer and also provide enough space to build habitats, solar panels, greenhouse and scientific laboratories. Before landing our spacecraft will scan the surface using cameras, large rocks and dangerous area. After landing, drones and rovers will inspect the area before astronauts begin building and habitat and scientific research. Living on Mars is very challenging because its environment is very different from Earth's. The atmosphere is very thin and is made mostly of carbon dioxide, so astronauts cannot breathe without life support system. The average temperature is around minus 60 degrees Celsius, although it can become even cooling during night. Mars also has only 38% Earth's gravity, which can weaken muscles and bones during long mission. And other challenge is powerful dust storms that can reduce visibility, cover solar panels, and damage scientific instruments. To overcome these challenges, our mission includes a pressurized habitat, radiation protection, weather monitoring system, reliable power source, water recycling system, and health monitoring system. These systems will help astronauts live and work safely throughout the mission. Next slide. One of the main objectives Next slide. One of the main scientific objectives of our mission is to study the geology and climate history of Mars. Scientists believe that millions of years ago, Mars had a warmer climate, flowing rivers, lakes, and possibly a thicker atmosphere. To understand how the planet changed over time, astronauts will explore different rock layers, volcanoes, minerals, and ancient biological formation. Using drones and rover, we will first survey the area and identify scientifically important locations. Then astronauts will collect rock samples from both the surface and robotic arm through drilling equipment. The collecting samples will be analyzed in our habitat laboratory using microscope, spectrometers, and often scientific instruments. If we discover minerals that only form in the presence of water, it will provide strong evidence that Mars only had a much weather environment. This search will help us understand the geological evolution of Mars and also identify suitable location for future human settlement. Next slide. Water is one of the more valuable resource on Mars because it is essential for human survival. Before collecting samples, we will use ground penetrating radar, neutron spectrometers, and thermal underground ice and water rich area. After identifying suitable location, astronauts will use a drilling machine to collect soil, rock, and the samples from different depths. These samples will be transported safely to the Habitat laboratory where they will be examined using microscope, chemical analyzers, and spectrometers. Our scientists will search for organic molecules, hydrated minerals, and other biosignatures that may indicate whether microbial life existence on Mars in the past or could still exist today. If an important evidence is found, the sample will be pressured for future mission and possible turn to Earth.
My name is Simab. I will explain scientific research and ISRU. Our mission is not only about exploring Mars, but also about preparing for future human settlements. Throughout the mission, we will monitor radiation, weather, temperature, wind speeds, and dust levels using advanced scientific instruments. At the same time, we will test ISRU, which stands for Instru Resource Utilization. This technology allows astronauts to use Martian resources instead of depending completely on Earth. Underground ice will be extracted, melted, purified, and converted into drinking water. Using electrolysis, water will also be separated into oxygen for breathing and hydrogen for future rocket fuel. Testing these technologies is very important because they will make future Mars mission more sustainable, safer, and much less expensive. Next slide. Mars habitat. Our habitat will be the astronauts' home on Mars, so it must provide a safe and comfortable place to live and work. After landing, robotic system will first inspect the landing area and prepare the ground. The habitat modules will then be unloaded from the spacecraft and converted into together to form one complete living station. Once the habitat is assembled, robotic vehicle will cover it with Martian soil called regolith. This natural layer will protect crew from harmful radiation, micrometeorites, extreme temperature, and dust inside the habitat. Life support system will automatically maintain oxygen level, air pressure, temperature, and humidity to create an Earth-like environment. The habitat will include sleeping cabin, a laboratory, a medical room, a kitchen, storage areas, a hygiene section, and exercise area, and a communication room. Our habitat will also have a modular designs, which mean that additional sections can easily be attached in the future as more sustainable arrive and new facilities are needed. This design makes the habitat suitable not only for our mission but also for future more settlements. Next slides. Life support, water and food search system. Long-term survival on Mars depends on reliable life support, water and food system. Inside the habitat, the life support system will continuously clean the air. Carbon dioxide released by the astronauts will be removed using carbon dioxide scrubbers, while an oxygen generation system will supply fresh oxygen. Sensor installed throughout the habitat will continuously monitor oxygen level, air pressure, humidity, and temperature. If any value change, the system will automatically adjust it to keep the environment safe. Water will come from two sources. First, underground ice will be located using scientific instrument. A drilling machine will extract the ice, which will then be tanks for drinking, cooking, hygiene, and scientific use. Second, wastewater for washing, cooking, and moisture collected from the air will be recycled using a water recovery system. This will reduce water waste and provide a greenhouse using a hydroponic system where plants grow nutrient-rich water instead of soil. LED grow lights will provide artificial sunlight while automatic sensors will control water, nutrients, temperature and humidity. These plants will provide fresh food and also help improve air quality inside the habitat. Next slides. Power system. Every mission system depends on a continuous and reliable supply of electricity. After landing, the solar panels will automatically unfold and begin converting sunlight into electrical energy. This electricity will power the habitat, laboratory, communication equipment, life support systems, greenhouse, and scientific instruments during the daytime. Because Mars has long nights and frequent dust storms, our mission will also use a small nuclear reactor. The reactor will The reactor will produce electricity continuously regardless of weather or sunlight, ensuring that all essential systems remain operational at all times. A power management system will distribute electricity to different parts of the habitat according to their needs. Backup batteries will store extra electricity generated during normal operation. If the solar panels or nuclear reactor temporarily stop supplying power, the batteries will automatically provide electricity until the main power source is restored. Using these three systems together, solar panels, a nuclear reactor, and backup batteries will provide a safe, stable, and uninterrupted power supply throughout the Mars mission. Thank you.
One, myself Ume Kulsum. Today I am going to talk about Mars technology. Advanced technology will play an important role in every stage of our mission. Before astronauts being exploring autonomous, drones will fly over the area to capture high resolution, create detailed 3D maps, and identify safe routes. Pressurized rovers will transport astronauts, scientific equipment, and collected samples across the Martian surface while protecting the crew from the harsh environment. Our rotary percussive drilling systems will collect rock, soil, and ice samples from beneath the surface for scientific analysis. These samples will then be transported safely to the habitat laboratory for detailed examination. The communication system will allow the crew to exchange information with mission control on Earth. Even though there will be a communication delay due to long distance, our mission will also demonstrate ISRU technology by extracting underground ice, purifying it into drinking water, and producing oxygen through electrolysis. Using marginal resources instead of depending entirely on Earth will make future human mission more sustainable and cost effective. Next slide. Crew selection and living on Mars. Now, let us talk about the people who will make this mission successful. A Mars mission cannot be completed by one person. It requires a highly trained team where every member has a specific responsibility and also knows how to support the others when needed. Our mission includes 4 crew members. Aksa will serve as the mission commander and will lead the entire mission. She will coordinate daily activities, make important decisions, and maintain communication with mission control on Earth. Sima will work as a systems and engineering officer. She will maintain the habitat, power system, communication system, rovers, and all scientific equipment. If any technical problem occurs, she will diagnose and repair it to keep the mission running safely. Rabia will be the science and research officer. She will lead geological studies, search for water, collect rock, soil, and ice samples, and supervise all scientific experiments. She will also analyze the collected data and prepare important samples for future study. Ume Kulsum will be the medical and life support officer. She will monitor the crew physical and mental health, provide medical care when required, manage food and water supplies, and, and ensures that oxygen, air quality, and life support systems continue to operate properly. Before traveling to Mars, every crew members will complete extensive physical, technical, and emergency training. They will learn how to operate spacecraft system, use scientific instruments, drive rovers, perform drilling, collect samples, and respond to medical or technical emergencies. Living on Mars will require discipline and teamwork. Next slide. Health and human adaptation. Living on Mars is very different from living on Earth. The crew will face low gravity, high radiation, extreme temperature, and long periods of isolation. Therefore, protecting the astronauts' health will be one of the highest priorities of our mission. Mars has only 30% of Earth's gravity. Because of this, astronauts may lose muscle strength and bone density during long mission. To reduce these effects, every crew members will exercise for about 2 hours every day using treadmill, resistance exercise machine, and stationary bicycle inside the habitat. Their health will be monitored regularly so the exercise program can be adjusted if needed. To protect the crew, the habitat will be because Mars has a very thin atmosphere and no global magnetic field. To protect the crew, the habitat will be covered with Martian salt called regolith, which acts as a natural radiation shield. Each astronaut will also wear a covered with Martians wear a personal radiation monitor and radiation sensors around the habitat will continuously measure radiation levels. During a solar storm, the crew will immediately move to a special protected radiation shelters. Regular health checks will include monitoring heart rate, blood pressure, oxygen level, body temperature, and overall physical condition. Next slide. Safety and emergency procedure. Safety is one of the most important of our Mars mission design. Every system has been designed to protect the crew during both normal operation and unexpected emergencies. Whenever astronauts leave the habitat to explore Mars, they will wear advanced pressurized spacesuits. These suits will provide oxygen, maintain body temperature, protect against harmful radiation, and prevent Martian dust from entering the suit. Before every EVA, the crew will carefully inspect the spacesuits, communication devices, batteries, oxygen tanks, and emergency equipment to ensure everything is worked correctly. The crew will leave the habitat through an air clock and use the pressurized rovers whenever traveling long distance. During every EVA, mission control and the mission commander will continuously monitor the astronauts' location, health, and communication system. Mars is also known for powerful dust storm. Our habitat will include a protected emergency shelter where astronauts can stay safely until the storm passes. Thank you. Our mission combines science, engineering, and human operation to help astronauts travel safely live on Mars, conduct valuable scientific research. We have carefully planned every stage of the mission, from landing and habitat constructions of water production, life support, and crew safety. We believe that this mission design can support future space exploration and bring us one step closer to establishing a human presence on Mars. Thank you for your attention.